So we're going to be looking at some of the ways you can set up a tachometer signal in ObserVIEW. There's kind of three main ways that you can do this. You can record an actual tachometer in the field. You can generate a tachometer based on a time spectrogram, and you can create a math channel with an angular velocity unit. So I'm going to kind of walk through briefly those three ways to do that. So this first way, as you can see, we already have a tach signal. So this was a case where out in the field we measured an actual physical tachometer. We measured some frequencies, some angular velocity measurements. And as you can see, it goes from roughly 900 RPM up to about 1800 RPM. And what we can actually do with this is if we go to order analysis up here, we can see that in the tach channel, it's already got it selected. Whenever the software sees a trace with an angular velocity unit, it assumes that it can be used as a tach, which in this case is what we're going to do. So then we can see that tachometer. You just click Add Tach Spectrogram. It automatically finds that range. So it does from 500 to 2500 just to give us a rough range, but then you can dial that in by clicking Find Tach Range, and it gives us that 900 to 1800 RPM range. And that just kind of gives you a rough tach spectrogram. This is the easiest way to deal with tachs, is to just go out and physically use an actual tachometer. Sometimes, though, you can't do that. So I will pull up a different data set and show you the two other ways that we can deal with that. So here we have a set of data where there was just a drill, and we didn't record a tachometer in that data set. So what we can actually do is we go to Add Graph, we put in a time spectrogram. And what this does is it finds that frequency value during the time of the test and puts those values in as a color. What you can actually do, if you go to Properties, you can view that as a 3D plot, which sometimes can be a little helpful because you can see those frequency values next to, you can actually see those acceleration values as well. We'll go back to 2D though, and what we can do is if you go look at this Properties tab, on the bottom we have a Math Expression Builder. If we click Start Edit, you can see this cursor. It gives us some options. You can see press Insert key to add a point and press Escape key to cancel. You also can just click to add a point. So what I'm going to do is just follow this frequency curve, because let's just assume that that's the rough signal that we want to use. So I can just keep clicking, throwing in points roughly along this curve, and end it with a straight line out that way. And then what we can do is it put in this trace, and what we'd want to do is generate. What that does is it generates a math channel. So if we go up into math and click on that, you can see it generated a set of data points that follows this line. And then what we want to do is stop edit so it doesn't think we're trying to add more to the spectrogram. And if we go back to that order analysis tab, you can see that it has a generated tach option, because what that did is it knows that there's a frequency in there. It's assuming you want a tach. So once again, it's assuming a certain range, but if we do Find Tach Range, it dials it in what that RPM will be for those values. Click Add Tach Spectrogram, and it throws in our tach-based spectrogram as opposed to the time spectrogram. So that's the way to use the Math Expression Builder from the time spectrogram to add a math channel. The final way that you can do this is, I'll pull up a different file. We'll just do this planar blade test. Now let's just say that for this data, what we can do is what we did previously. We have a tach spectrogram, and we can see that there's quite an easy line that we could trace and do all that. But let's say that I know that in the background of this data set, there was a certain angular velocity that was present, some frequency, some rotational value. Instead of going through that process of putting that down, what I could do is, let's say we know that there's 19,800 revolutions per second present in this. What I can do is make a math channel, calculate that, bring it in, and it does put it in there. We don't really need that. If we go back up to order analysis, that tach channel, it finds that math channel, and we can add a tach spectrogram based on that. Now it asks this, it says no tachometer data in this time range, and what you can do is automatically find that min-max tach range. And we can see that even though it is constant, which we can see that the software figures that out, it puts this, usually you can choose between up and down. It finds that it's constant because you're sitting at one value, and it generates that tach based on your math channel. So that is all for the generating tachs and using tach data in ObserVIEW, just kind of a baseline of what you can do. And these are things that you would typically do when leading up to creating a sign on random test in your STAG software. So from here, then you would add your orders and then continue on to generating your sign on random test.